Hello, everyone. Welcome to this workshop today. I'm going to give everyone just sort of like 30 seconds to a minute to join because we're like 30 seconds early. I've kept an eye on the chat. It's great to see so many of you here. If you can hear me and see everything perfectly, please could you give me a thumbs up or a wave, just so I know. Also, through the workshop, of course, things do go wrong sometimes with like internet. If you can't hear me at any point, if anything's not clear, please go ahead and put something in the chat. But yeah, I'll just wait for just to make sure everyone can hear me, and then we will get started. Perfect. Perfect. I can see a bunch of waves coming through. Sounds like everyone can hear me. Okay, so yeah, like I said, welcome to this workshop on who's designing your system, you or your agent. If we've not met before, just go ahead and introduce myself. My name's Alex. I'm a software engineer. I'm technical education lead at VitaBrains, working on unlearn.dev and certificates.dev as well, which is why you're here. I've been a software engineer for about 15 years now, and I've taught software engineering for about 10 years. Spent 10 years teaching Laravel and PHP in a company that was acquired last year. And yeah, I'm lucky enough to be working on Unlearn and certificates.dev now. I'm just going to really quickly talk about Unlearn because we don't usually do this. We have a separate product that teaches software engineers in the AI era, basically. So I'm really proud, as well as on the certificate side, to also be part of unlearn.dev too. I'll speak a little bit more about this as we go. And the reason that I bring this up is that we are going to be working on a code base that we use within Unlearn as well. We're also going to be building a skill later as well, which also ties into Unlearn. So everything sort of comes under the same umbrella. So I'd love to see you over there. But like I said, we'll speak a little bit more about that later. So yeah, my name's Alex, and if we've not met before, I'm really excited to meet you. And as well, if you are not familiar with certificates.dev, I just want to really quickly talk a little bit about what we do. So we provide certificates in multiple languages and frameworks for the modern developer. We've certified over 8,000 developers, both individually and across 600 companies. We've done that across 95 countries, and we are trusted by some of the biggest companies in the world, both for certificates being obtained and also to certificates being recognized as well. And the great part about this is that we partner with some of the best in the industry to not only create but review these exams and certificates, but also host workshops like this as well. So we're really proud to do all of that. Okay, let's talk about what you're here for, which is the agenda for today. So the way that we run the workshops, or the way that I'm going to run the workshop today, is we are going to do a sort of talk practical. So we're doing 3 practicals today, and in between there, I'm basically going to talk to you about how to get your agent to structure your applications how you want. So there's a huge amount in here. This is, of course, not going to cover everything. I wish we had all day to do this, but we only have 3 hours. But this is going to give you, my goal here is to give you the fundamentals to go away and make sure that your agents are following the rules that you set, whatever they are. I'm not going to dictate to you how you should structure your applications, but I'm going to help you force your agents as much as possible to follow your conventions. So we're going to start with reading the decisions. So we're basically going to work out, like, how do we know when an agent has gone wrong and made a really bad architectural decision? And then we're going to do our practical and go for a break to grab a drink or whatever. Then we're going to go in to look at actually encoding what we've learned and writing down rules that actually work. So rather than just, dumping something in agents.md, how do we actually enforce this? The second practical is going to be breaking your own rules. So you're going to either open up the feedback pit code base, which is the one that we use over on unlearn.dev for all of our content there. And we have this merge duplicate ideas branch, which we're going to do this on, or you can use your own code base. It's probably a good idea to use your own code base for these practicals, but we've got one here if you are stuck. So we're going to try to break the rules that we set for ourselves to harden them as much as possible. And then we're going to talk about over and under engineering. And then finally, we're going to go to the third practical where we're going to build out a skill live together. I'm going to do this on screen. You can either watch or follow along. It's entirely up to you. So a little bit of housekeeping just before we get started. Please participate in the chat if you want to shout out any answers, if you want to make a comment on anything that I've said. Any answers to specific questions, or if you have any questions, please feel free to add them into the chat. I've got the chat up on screen, so if we've got any kind of downtime, I can answer them. I'll be on my laptop during the break, so I'll be able to answer any questions there. And we also have a Q&A at the end as well. So with that said, please drop in questions as we go. There are no silly questions. There are no too simple questions. I might have explained something totally wrong, in which case you can ask the question, what did you mean? It's, whatever you want to do. So please drop as many questions in as you can, and they'll be collected up for the end. Also, the prep for this, I wanted to keep really simple because I much prefer that you dive into your own code base to do this, but please go through and read the prep guide. In the first break is fine, just so you get an idea of what we are doing through the practicals today. Okay, so again, just before we start, we recently launched the AI certification. You might have already seen this since you've come through to an AI certification certificates.dev workshop. But specifically for you joining today, we've opened up a side door access to our AI certification. So this is an exclusive pre-order window just for this workshop, so no one else will get access to this offer. This is the absolute best price we will offer for this as well, so you will not be able to get this in a Black Friday. This will also include specifically for everyone in the workshop today, because we're really thankful for your time, live onboarding and Q&A with me as well. That's exclusive to you. And this closes today at midnight. So the link's up on the screen, or you can scan this QR code. I'll have this throughout the workshop as well, because this is just something that you probably don't want to miss. So you'll be able to do that, or if you want the link, it's in the chat as well. Okay, so the first section, let's get started. I'm incredibly excited about that because, like I said, I love architecture. I spent a long time teaching software engineering, and architecture is incredibly important, particularly in the age of agents, because before we could make some pretty bad decisions as developers, but if you think about it, now we're handing that over to an agent. If our agent is making bad decisions, they're accelerated even 100 times. So usually when you're working with a agent, you ask for a feature and you get working code. Agents are pretty good at, outputting correct code now. The issue is you also get a set of decisions that have been made without you. Your agents will either assume things or they'll neglect to add things in. So the good thing about bugs, if you can say that, is that they announce themselves. So for example, you might get a failing test, in which case your agent has done something wrong. Your agent might even self-correct an error, as long as you've got tests being run as part of your workflow. You'll probably get an error somewhere, either when you compile your application, or in this case, you'll get a type error in the browser if something goes wrong. Or at the very worst case, but at least you do get the feedback, you might get customers saying that refunds have broken, something else has broken. So either way with bugs, you get some sort of feedback, even if that's delayed. Now, the problem with structural decisions with your applications in terms of architecture is that they're silent. So nothing really fails. Nothing warns you about a bad architectural decision. Tests are usually green. If they're well-written tests, they shouldn't be testing the architecture, but you'll get that you'll get green back anyway, and everything looks good to go. And customers will be happy because, of course, customers are not using your code base; they're using your product, so they're happy. But I've added here for now because a little bit later down the line they might become unhappy due to your architectural decisions, which we'll talk about, your agents' architectural decisions, which of course we will cover. So the costs of not taking architecture seriously upfront and while you are developing arrive months later. For example, every fix you make or every feature you add tends to break something. We've all been in this position before, whether it's non-agent or agent written code, where we fix one thing and it breaks something else. The same bugs keep coming back over and over again, time and time again, due to the way that we've structured an application, or just simply no one wants to touch that. And we've been in this position before, again, with non-agent written code. And that's a theme throughout this, that whatever we as developers generally do wrong, an agent will always accelerate that. We'll get to the point where we ask, who designed this? And of course, the answer is no one really, because there's a bunch of decisions that have been made without you. About agents is they tend to add code and they rarely consolidate. And this is actually backed up with data. So this is just one vendor's analysis. So we're going to take this with a pinch of salt. It's correlational. It's not absolute gospel here. But Git Clear analyzed 211 million changed lines. And a stat here from 2023 to 2026 showed that duplicated blocks per million of changed lines went from 40 to 73. Now, in plain English, what does that mean? Well, it means agents paste a copy of code that already exists in one location instead of trying to reuse it. They basically copy a solution, not literally paste, but they'll generally copy a solution rather than try to refactor and add this to make the structure or your architecture make more sense. Another stat here from this analysis is that of changed lines that are moved code, this went from 21% to 3.8%. So again, what does that mean? Well, it means that because moved code means refactoring things, when you move something, it's nearly stopped happening. So code stays in the same place and agents are adding code on top of what already exists. Now, if you've ever vibe coded something, or when you start using an agent, you might be stuck in this cycle at the moment. Pretty much all of us have been at one point or another. And the other question is, why do agents actually drift? There's a few reasons which I've tried to consolidate. They're all very similar. The first is that common beats custom. So the conventions that you have in your code base currently, or the framework that you're working with, are such a tiny signal next to the millions of code bases that have been used in training data. And let's be honest, the millions of code bases that have been used in training data are not necessarily shining examples of the best way to architect applications. There is lots of bad code out there. So who knows what this has been trained on? Second of all, simple beats structured. So a quick solution always beats something that is a lot more structured, because your agent is trying to get this to work properly the first time, and it doesn't really care about looking into the future and working out the best structure for things. So every solution has a quick version and a structured version. It's usually the quick one that we end up with. And also, familiar beats framework specific. So your agent will reach for what it's seen most, not what your project does. And this is similar to number one. This is more framework specific. So as an example for this, you'll get, a function being built for something that already exists within the framework. So, this is, again, similar to one, but framework specific. So they're just a few reasons that agents drift. There are, of course, a lot more technical, in-depth reasons, but if we use these as the things that we that work on, we can, try to manipulate our agents to do what we want. We also have a timing problem when we are working with agents. So let's say we have a bunch of rules that are defined at the start of a session as we are going to build a feature. Well, Of course, as you are either in plan mode or if you're using something like spec-driven development, or even if you're just chatting with your agent before you start to implement a feature, fix a bug, or do a refactor, time goes by and you have dozens of messages which fill up your context window, they pollute your context. And effectively, what happens is by the time the code gets written, rules sometimes get ignored because your agent is almost confused about what has happened in the past. You might get some conflicting messages that conflict against your rules as well. So this is another problem which we don't often think about, and I'm going to be referring back to this a little bit later, particularly in two of the practicals that we do, and that's about context clearing and how important that is. And just to be clear, your agents aren't ignoring your rules on purpose, but it will always pay attention to what came most recently, whether that's something you've encoded somewhere or whether it's something you've been chatting about. So this is a really important point to take away. Okay, let's look at four things, again, backed up by data, that agents reliably do, almost always. They have selective amnesia. So it forgets code that it already wrote. Either it doesn't look for it, or it just doesn't take it into account, or it's not similar enough to the problem you're redescribing. So it just goes ahead and writes it again. So you've already got a structure somewhere in your code base, or you've used a convention somewhere in your code base. Well, it will just rewrite it again. And this particularly applies to architecture because architecture needs to be consistent. So if it does ignore stuff, that's a problem. Also, library aversion. So it will hand roll things that already exist as libraries, less to do with architecture, but still, this could come into it. This is definitely a really good architecture point. Agents have deletion phobia, which is a good thing, but it's also a bad thing. So it usually won't delete code. It will favor adding code. So a lot of dead code starts to accumulate in your code base because it would rather add something on to fix a problem rather than go back and look at the solution, delete something that it probably shouldn't be there and refactor it. And also we have a complexity spiral with agents where it will patch rather than refactor. So sort of similar to deletion phobia. And you just get that compounding complexity within your code base. So agents generally write good code over and over, assuming you've put some basic rules in place. But in a different style every single time can be the issue, or will be the issue at some point. And that's when you start to get into hard to maintain applications, you getting confused, agents getting confused, performance suffering, security suffering, basically everything. Architecture isn't just about how do we make our applications look pretty, they're about designing our applications so they're easy to reason about and easy to update. So the goal here is every change that we make follows the same pattern as the rest of the code we already have, or a pattern that we've predefined. And to be really clear, this isn't super strict. So don't worry if one change that you make breaks a pattern. For example, let's say that you need to add a quick endpoint to do something, and it just adds, stuff into a controller. And actually, in your application, you're using the action class pattern. Well, don't worry too much if that's the case, but it's about this compounding over time that really creates the mess. So, what you're going to leave with today is a way to read or reason about changes structurally within agents. That's the first practical that we're going to do. And of course, I'm going to talk a lot about this as well. We are really importantly going to talk about how we write rules that actually hold up. So rather than just dumping stuff into agents.md, how do we actually get our agents to follow these? And we're going to build a skill file together as well that runs these checks for you. And when you come away from this, you can adapt this skill to your own team, organization, or your own project. So you can take this as a really good starting point and run with it. And really, really importantly, I think I mentioned this before. I'm not going to tell you how to architect your applications at all because it really depends on the language you're using, the framework, the industry you're in. But I'm going to make sure you're still the one actually architecting it. And again, we can't cover everything, but this is hopefully going to give you a really, really good start because this is so important. Okay, so with that done, let's go into the second section, which is reading the decisions. So when we're working with code, when we're reviewing code, we usually do two kind of different reviews. Does this work? We look at bugs, edge cases, security, performance, all of that stuff. And actually, most of what's out there in terms of the importance of building with agents focuses on this stuff. But actually, does this belong here? Is a really important question. And we've got things like where things live, who owns the data, what depends on what, and often overlooked how failures are handled. Most of the time, like I said, we focus on the first one, and today we are talking about the second, about the not just the actual architecture of your applications, but how we think about where everything lives, who owns the data, and what depends on what. So when we look at changes, there are four elements to every change. The first one is boundary placement. Basically, is this thing in the right place? Second of all is data ownership. Who else writes this data? That could be somewhere else in your application or another consumer. Dependency direction. So what does this thing now depend on that we've just added with our agent? And also error handling. What happens when this breaks? Each of these four basically encompass good architecture and the basis of good architecture. So we're going to go through each one of these now. So the first of the four questions, boundary placement, but shortened to, is this in the right place? That's the question we want to be asking ourselves for. And for each of these questions, I'm going to give you some red flags that you can look out for and what you should probably do to rectify these. And again, please take this with a pinch of salt, because the red flags are what we want to focus on, but your solution to this and how you do this might be different. And this is also an overview so that you can go a lot deeper to this, go a lot deeper into this once you've got the fundamentals. So the first red flag of, is this in the right place, would be a business rule. So something that belongs as a business rule type, like in your application, written inside of a controller or a component. Basically, something that feels like it's isolated away from something that should be a more structural, global part of your application that every one or every part of your code should have access to. Basic things like calculations or checks mixed in with code that displays things. So mixing logic and an output or display is pretty much always a no-go, and agents do this. And another thing to look out for is code going wherever the agent was. And by that, I don't necessarily mean like you've CD'd into a specific directory and the agent write code there, but within the context of what you're talking about as well. So, for example, you might be talking about one section of your application, or you might have finished up a feature, then you might go to another area of your application, and it might focus on something that's completely wrong and misjudge how your application should be structured. The agents definitely don't take your entire code base and push the whole up as a full picture. So you need to be really careful about this. So instead, what we should do is ask if another part of our application needed this business rule or something else tomorrow, would it find it? If not, we want to move that into a shared place and make everything call that. So we'll look at some examples of that. We're going to look at some real code examples of this later. But basically, we don't want anything hidden away somewhere. The structure, the architecture of our application should be such that something that should be visible everywhere should be visible everywhere. So, for example, in views and components, we should format and display. Possibly not even format, but that's another argument. But we should definitely not do anything more than this. Inside of controllers or any kind of handler, we should translate the request, call a service, or whatever you want to call it, and then return a response, whether that's a JSON response or a redirect or an error, whatever. Services and domain should be where the decisions live. So all of your business rules should live here. And again, bear in mind that these are just my suggestions, but the whole point of this is that we want to map these up front. So again, please feel free if you have different architectural preferences to think about this in terms of your own. And also often neglected the database. So this enforces what almost always should be true. So like if something's unique required, if you should only have one active row for something, and this is the last line of the defense as well. So again, like I said, these aren't hard rules, but yours just need to be consistent. So just think about this in the back of your mind as we go through. For the second question, who else writes this data, which comes under data ownership? This is incredibly important. And I see agents get this wrong quite a bit. So red flags to look out for are the change writes data that another part of the app already writes. So you add a feature that touches another part of your application, but somewhere else already writes to that via a different mechanism. Now, that's not necessarily and automatically a bad thing, but that can signal that your architecture isn't set up to handle this properly, and it can become an issue in the future, particularly if one part needs to change and the other part doesn't change. Um, the other red flag is that the same thing or fact or value, whatever you want to say, is saved in two places with a comment like keep in sync. And this is an actual comment that I ripped out of a change. Most of the examples here are from real code and agents written, where it's basically saying we want to keep this in sync. It's almost like the agent is giving itself a note to keep something in sync. As an example, a discount code, let's say that you store this one place and store it somewhere else as well. Now, them two values need to be kept in sync as well. Another thing which I've seen happen a lot is writing straight to a database table that belongs to another part of the app. Instead of going through the front door of like whatever needs to allow access to writing that. So instead, give every piece of data one owner. Rights need to go through the owner, and everything else can read from that. And we don't want any copies anywhere. So again, this depends on your framework or language or however you're building your application. But basically, we don't want multiple copies of two things, and we don't want two things writing to play two sections of our application writing to the same place always. Like I said, not automatically bad, but can signal an issue. Okay, so a few examples here, just like pulled out of projects that I've worked on. A posts count column, for example, a stored total next to line items rather than calculating these up. A is premium flag, which mirrors whether a subscription is actually active. A status that's copied in another table, so we have a syncing issue, or for example, a count that's kept in both Redis and the database. So these are all copies of data that live elsewhere, and sooner or later they're going to disagree at some point. So the next one is dependency direction. The question is, what does this now depend on? So red flags for this are business rules who have knowledge about requests, sessions, and responses, which they probably shouldn't, because these are web things that should be at a controller level. And this happens a lot with agents. A model that suddenly knows about requests, sessions, or responses. Again, I've seen this quite a lot. Or code reaching inside of another module, so like its tables or its cache keys, instead of going through the front door, which is basically the predefined way to do things. So instead, the request in most MVC applications should stop at the controller. That should be turned into plain data, and then that passes it into whichever service. And business code never needs to see the request. And the reason that this is important is because that we might want to reuse this in other areas of our application. And again, agents will often just copy that to another place, which is why I think this is a really important one. Now, one thing that I always do with applications or features that I add with agents is a grep test. So you could build a skill for this, or just ask it to do this manually. But you want to search your core business code for words that should never, or you don't necessarily want to appear there. For example, things like requests, responses, sessions, and cookies, HTTP calls, view, rendering, and root is a little less important, but still I grep for these anyway, just to make sure that our agent isn't drifting. So agents mix web code into business rules all the time. And this generally works, so it doesn't care. And the reason that this is important is that you're left with business rules that you can't test. So you can't test very easily, at least, a thing that does an action that does something, or a business rule that does something, if it relies on a request, because you have to fake the entire request just to run the test. It also makes it very difficult to reuse things. So if it only works in one place, our agent will need to copy it. And like I mentioned before, agents generally have an aversion to removing code and they prefer to add. So it's more likely you're going to end up with a duplicate. And a business rule that breaks for unrelated reasons. So someone works on a feature elsewhere and it breaks somewhere else. That should really never happen. Okay, so the last one is error handling, which is again often overlooked, but good error handling is really key to the architecture of your application. So red flags you can look out for, which agents again do all the time, is catch blocks that do nothing with an error. They just either create an empty block or they comment it out, assuming that you are going to go ahead and fill it in. They'll sometimes swallow errors and just return like a null value or a false value, and then you get an error elsewhere, or you have to monitor and chain it down. And something like a newly invented error type that your existing handling doesn't know how to catch. So these are just a few, but of course there are more. Now, a really good rule that I like to keep in mind with errors, particularly with agentic engineering, because you're moving so fast and you need a way to reliably handle errors, is every catch or every failure check does one of three things. And if it doesn't do any of these, then it's technically hiding a failure. One is recovering. So you want to either recover the error and go ahead and either let the user know, or you want to offer them an alternative, like something has gone wrong, let's start again, or let's do something else. You want to retry. For example, if you send an email and it fails, do we just say, oh, okay, it's failed? Well, usually not, depending on the severity of the email. Like if it's an invoice or something, we want to retry that a specified amount of times. Or you want to report the error, or you want to do report and recover and retry, so you can go in and you can figure out what's going wrong and fix this up. So these three things, doing one of these three things, preferably the first two, is really important. So here's a really simple example. This is from the Laravel framework. And again, this is real code that I've pulled out of some projects. And then I've written the correct way that this should be done. So this is sending a receipt to a user. So we're wrapping a mail in a try catch block. So if this fails for any reason, for example, if our mail provider is down, it's going to catch this error. And it's basically going to add a comment. Now, my agent didn't add "it's probably fine," but it did add the comment just here. And it just would do nothing, which is, totally unacceptable. So again, this is a shortened down version of effectively a job that goes into our queue and it retries 3 times. And we'll look at an example of this again later when we look at the first practical. But we'll send the email, put it into a queue. It will try 3 times, and it should alert us if the fourth attempt actually failed as well. So this is much better. And this seems complex. Agents generally won't do this the first time around. They will do the first thing just here, which exactly what they did. So hopefully that makes sense. But if not, let's put all of these 4 questions into one single change. And again, this is a real example, but I've sort of condensed this down a little bit. This is, let's imagine we ask our agent to create the ability to refund an order. We want to remove loyalty points if they've been earned, or remove loyalty points it did earn. And then we want to email the customer to confirm the refund. So pretty simple. The agent delivers this. It does use a service here. It refunds the payment. It goes ahead and creates a negative value in the loyalty point ledger. And then it goes ahead and sends the email. So already you should start to see some of the issues with this. So the first one is that we have a boundary placement here where the whole refund workflow lives inside of this controller. So if you ever need to refund from anywhere else, an admin panel, a webhook, a CLI command, your agent will rewrite it. So basically everything is inside this one method. We have a data ownership issue here. It writes loyalty data directly and it guesses the rate it has to reverse. So we've got a calculation here basically within a controller, and our application can't access this anywhere else. It has to either duplicate it, which creates that issue where we have to keep 2 things in sync, or it just it just never runs elsewhere. We also have a dependency direction issue here. So orders now depend on the loyalty table. So if we rename columns or do anything else, it could break refunds. And we also have an error handling issue, which obviously we've already discussed, where it just catches a throwable and no one ever finds out that the email didn't come through. So here's what, again, this is an incredibly simplified example. In reality, there would be database transactions here that we could roll back, for example, but this is just a simplified version of how a potential ideal would look, specifically within a Laravel framework. This would be what the controller looks like, because the controller's job is to take the request. In this case, we get a model through the request by taking the ID or the UUID out of the request, automatically, magically behind the scenes within the framework, grabbing the order and then passing that through to a refund service. So that refund service, oh, this controller now just hands it over to the service. The refund service now looks like this. So this, again, looks very simple. In reality here, if something broke, we'd want to revert. But we would access a payment service to refund, a loyalty service to reverse this, and then we would send an email, but we wouldn't do that directly in here. We would go ahead and dispatch this onto our queue. So the whole workflow now lives in one place and anything can use this. So if we get another task in to add this to our admin panel, super simple. We basically just do this within our admin panel because we've already got a service here. So this is, again, comes under boundary placement. Anything can call this now. So for the loyalty service, this reverses its own points using its own rules. So again, this is encoded in one place, and this comes under data ownership and dependency direction. And that's as simple as it gets for that. And here's the email. Here's ideally what this would look like. We have two ways to handle this failure. The first way is a retry. So if the first email fails, it will try another 2 times. And then if it finally fails, or if it does fail, it will always report this so we can check this out and see what went wrong. And don't worry if you don't understand the code here. Again, it's, we can't cover every single framework, but there will be some way to handle this in whichever framework you work in. So nothing gets swallowed here. And of course, that comes under error handling. So for the bad stuff, none of this gets reported back to you in the summary that your agent gives you. It basically works, which is the worrying thing. So everything works here. So hopefully that gives you a good idea about the kinds of things that we should be focusing on and the general things that agents do. We've got a huge amount more to cover here, and more interestingly, how to make sure our agent follows the rules that I've demonstrated here. We're going to go for a 10-minute break just to grab a drink, and we'll be back and we will start to work on our first practical. So I'll be back in a bit. And see you in a moment. Okay, we've got about 30 seconds just to wait for everyone to come back. If you have gone ahead and got side door access to the AI certification in the break, we really appreciate that. I'm incredibly excited about this. One of the really difficult things about working with AI is that it's really difficult to prove that you can actually work with AI. For example, all of the stuff that we're going through in the workshop today, how do you prove that you understand that? Anyone can pick up a coding agent and get a pretty good result. But of course, that's not the sustainable way to do things. So we really appreciate if you have signed up, and we are really thankful for that. And we're happy that we can offer it at this price as well. Also, another great thing about this is that your support means we can run more of these workshops for free. And we generally run one a month. So it's really great that we can do that for everyone as well. Right. Okay. So welcome back. I can see more people joining here. So we are going to go into the first practical here, which is basically just going to be you shouting out what you think is wrong with a particular piece of code. So I absolutely love these. So let's get started. So the way that this works is I'm going to put some code up on the screen. Now, bear in mind, we're focusing on the architectural stuff here. So if I've included any other mistakes, please try and ignore them. You can shout them out if you want to. That's fine. You are going to put your answers in the chat. So basically what you think is architecturally wrong with a piece of code based on what we've just spoken about in the workshop. Or of course, if you spot any others, you can go ahead and add them as well. And then we're going to compare notes. So I've written down some of the things that I think could be better with these, and we'll see what you came up with as well. So there are no wrong answers. Like I said at the start, please feel free to add as much as you want in the chat. I'll be monitoring these as we go. We're going to have 2 minutes for each of the exercises, and we've got 5 rounds. The first round is a little bit easy, so we'll just give you a little taster, and then we'll get progressively harder. So this is the first one. I asked the agent to build the ability for customers to request a quote. This is what pretty much every other endpoint in our application looks like at the moment. And this is what the agent gave me. So I'm going to start the clock here. Please feel free to shout in the chat what you think is wrong with this. Okay, so we're already getting some fantastic answers. We've got about 50 seconds left. Okay, we've got 5 seconds left here. I'm seeing some amazing answers here. So thank you for everyone. This was I purposely added a super simple one with a side by side, just to sort of get us warmed up. Let's go through. I just want to point out, Colin, you gave an amazing answer as well, which I'm going to talk about as well. So I didn't think anyone would get that. So well done. Okay, so here we go. Validation. Loads of people got this one. It's written in line in the controller, and every other endpoint uses a form request. Now, this isn't about the fact that the second one is bad. Someone made a point that the second one is fine. There are, some issues in the second one, but structurally it can be okay. But the point is that the code in every other endpoint in our application is different to this one. So it's not followed the conventions that we have in the rest of our application, which, as we know, can be an issue. The second one is the logic runs right in the controller. Everywhere else we use a service for this. So yeah, pretty much just not matching up to what we already had. Again, lots of people got this one. We have hand rolled JSON. Every other endpoint returns a resource. Just on that point, we've got a good point where we don't have a type return for the controller, which wasn't added on purpose, but that's a really good point as well. One that I didn't think anyone would get, which was the status draft is a magic string. And let's assume that our app defines statuses as enums, which would be a good idea if we have these kind of statuses in the database. Not an enum in the database, but an enum structurally within our application. So that would have completely ignored that. And the general pattern here is that nothing's a bug. Like I said, it works. There's nothing necessarily wrong with it. But compared to our previous code, it is, of course, completely ignored almost everything, which is not good. Okay, the next one, a little bit more complex. I'm going to, well, this is basically just outputting a total on a page. It's a very simplified version of outputting a total. But let me start the countdown and you tell me what you think is wrong with this one. Good luck. Okay, so yeah, lots of people got this pretty quickly. It's yeah, the basic idea of this. Let's just go to the next slide here. Is the boundary placement. So yeah, almost everything, but also the VAT rate lives in the browser. It's a business rule on the client. The discount that's applied. Some of you mentioned the discount that's being applied. This already lives on the server or should live on the server as well. We've got display formatting fused into the maths as well. We've got a hard-coded currency symbol as well. We've now got two totals. So yeah, again, the difference between showing this on the UI and also calculating this in the backend. Well, actually, all of this should be calculated on the UI. And it's shocking that agents would do this, but they do this. And even if they do this in a very small way, and they don't do, this is a pretty extreme example, this still builds up to technical debt. And yeah, the invisible one is that if the VAT rate changes on the server, this shows the wrong total as well. So there's lots in here. Let's move on to the next one. So that was, again, I think a pretty easy one. So this one is a database one. Don't worry too much if the syntax here isn't familiar to you. The methods here are just creating that specific database type, column type in this migration. So yeah, again, I'm going to start the timer and let me know what you think is wrong with this one. Okay, so we've got about 5 seconds left here. We're getting some really good answers again. Just to be super clear, the ID method here does add a index to this, so that's not one of the issues. But pretty much all of the other answers here were absolutely spot on. So again, this is typical of what agents will do when they're creating migrations in whichever language, whichever framework or package you're using, if you are using migrations. So let's go through this. First of all, order ID has no foreign key. A bunch of you got that, which is so basically there's no integrity enforced, which is a really important one here. I think someone got this. I was sort of checking the chat as we were going along. Status is a free string, and every consumer has to guess the allowed values. Now, this isn't necessarily a bad thing on its own if you know what the enum values within your application are. So if we did have, if our architecture did use enums, we could use an enum sort of value plucked out of there, but as of yet, it's not, so it's still pretty bad. Someone did get this. Meta is a JSON blob, which we have a whole schema hiding inside one column. I've seen agents do this a lot. We have a data ownership issue where the courier email is basically copied onto every single row here. And it would be great to denormalize that by having another table to handle that, or some other mechanism. And we have a sort of invisible one where order ID isn't unique. So if we get to the situation where a job runs twice by accident, or someone clicks a button twice and we end up with multiple requests sent with no checks, we're going to end up with 2 duplicates on this. Okay, here's the next one. This is basically a invoice controller which passes a bunch of data down, formatting the total here. So let's start the timer and I will see what you guys think. Okay, we are nearly out of time. I have just seen a question pop up. Am I going to show methods to solve these issues? Absolutely. That's what we're here for. We're only a third way into the workshop. So we're definitely going to look at some solutions, not specifically for Laravel or PHP, of course, because not everyone uses that. But yeah, we definitely will. Okay, so yeah, I've been monitoring the chats. There were sort of two sides to this, really. The technical side, which we're not really focusing on this, was kind of a trick question because the app already had a money formatter. I didn't tell you that. Actually, someone sort of got to that point where there should be a global way to handle this, and yeah, really that should be the case. Now, in my case, this is already in a package, so ignore the sort of structural element to this. This money thing here, let's assume that this is a package and it formats it using a total and a currency, and everything is sort of tucked behind this nicely. So we have a config potentially in the background, and we have a consistent way to format this, whichever currency we're working in, all of that kind of stuff. Now, the reason this probably happened to me is because I live in the UK, I use pounds, so that is probably what it did. But were some other answers as well, which were completely correct. A function has been declared in an app that's basically built on support classes. It ignored the framework's structure, which again is a really important part of architecture. You don't want to ignore what the framework gives you. This happens to be a Laravel application. We could have actually used some native functions. I happen to use a package. We also have a hard-coded pound symbol. So obviously this is, just sort of like a technical issue, but lots of you saw this as well. And a division by 100 here assumes pence, which should be the case when we're working with any kind of currency. We should always be dealing in pence and cent, but this wasn't previously discussed. It's not been sort of encoded anywhere, so it's just assumed. We might be working on a legacy application where we're not using them. We might be using floating point integers for money values, which we shouldn't be doing, but again, we might be working on a legacy app. The invisible one here is that the invoice page and the email could potentially now show two different totals. So these two things could show two different totals. If one of these formatters changes in any way, we potentially get two different values. So we might get different sort of like rounding or, whatever we do. So super good answers here, but structurally this app already had a money formatter, or it should at least have a single simple way to do something rather than sticking a function, which someone rightly said inside of a controller. Even if it wasn't in a controller, it probably should be better. So this is very similar to the first one and what we've already spoken about, but there are a couple of other issues hiding in here. So this is just to reinforce this. Go ahead and shout out what you think could be better here. And I'll be back in 2 minutes. Okay, so we've got 10 seconds left. You are all too good. I think I need to make these harder in future. But yeah, let's go through with the answers because almost everyone has got all of them. The first and most obvious is that the workflow lives in the entire controller. Stuff like this is super important because if someone needs to cancel this from somewhere else, like they will do, like an admin panel, the agent is likely to rewrite it. Where we have a data ownership issue where we've got whether someone is subscribed stored twice. We've got one within the service we're using and one within the database, which there's not necessarily anything inherently wrong with. However, there's nothing here to suggest that this is kept up to date with any kind of synchronization, like in a webhook, if anything gets cancelled. So ideally, we'd want to know that, or we'd want to make that entirely clear. The controller calls the billing API directly, and the URL and the payload are not within some sort of service, which is probably an issue. So let's just take a look at this, remind ourselves we've got this request here over to this cancel endpoint, which, the structure of this isn't too bad, but it's just in the wrong place. And again, a really common one, the email failure is swallowed by an empty try catch. And also nothing checks, someone did get this, nothing checks that the billing call actually worked. So we end up the worst case scenario where someone, thinks their subscription is cancelled, but actually they're going to keep getting billed, which is not great. Okay, we're going to go for another break. After this, we're going to go back into another presentation where we're going to talk about how to actually fix these issues, how to encode them into your projects. So even if you don't agree with what I have put up structurally here, or if you have completely different rules, or if who knows what your project looks like, you will be able to take whatever rules you have and make sure your agent follows them. So we'll be back in around 10 minutes. Again, if you want to um, go ahead and pre-order the AI certification, I'll leave the QR code up on the screen here. We'd love to have you, and you'd get access to a lot more content like this, as well as, of course, the certification. So I will be back in 10 minutes, and I'll see you then. Okay, we're just about ready to get started again. I'll just give everyone a little bit of time to come back again. And of course, in the next section, we've spoken enough now about the kind of issues and spotting issues. But the most important thing is how to encode these into your application so these things don't happen. So if you have your own rules in the back of your head thinking, oh, I wish I could stop that happening with my agents, we're now going to talk about how to do that. The mechanism for this is quite simple, actually, but it's really the thinking around it and how you write these rules out that's the most important thing. So let's go ahead and get started. Hopefully, everyone's sort of joining back in now. I can see. Let's do this. So let's talk about writing our rules down. And the first thing is, where do rules live? Well, you might be sort of disappointed to know that really the best place to put these, at least for now, is in agents.md. There are other mechanisms we can use, but for the majority of what we're talking about, agents.md is a really good place. It depends on how you put it in there and the state of your agents.md file. So if you've not worked with agents.md MD before, this is loaded at the start of every single session and applies to your entire repository. And this is where all of your rules go, but we're going to put our design rules in there as well. But we also have scoped rules, which are rules that load when our agent works on matching files or within specific directories. So we have the ability, for example, to nest claude.md inside of different directories. Same with cursed rules, all that kind of stuff. So the important part about rules is they implement, they don't enforce things. And a stored instruction makes any other violations that you want to encode less likely, just not impossible. So here's the same rule to try to enforce some sort of architectural decision twice, but in two different ways. So most of us write this first kind. Now, I've purposely made this as vague as possible, but essentially what we want to say is keep our app layers separate. You know, this is incredibly vague, but you would write something similar to this. I definitely have many, many times. And the problem with a rule like this is it matches everything, but nothing at the same time. What we want to do is we want to write very specific rules. So, for example, files in app domain must not import from app HTTP or Illuminate HTTP. Basically, we want to keep any web stuff out of our domain layer. And this rule should, is a lot clearer. So either this breaks or it doesn't. And also we can use things like static analysis for this, linting. There's a bunch of other things that we can do. The really important part of this, and I'm going to be honest, if you take one thing away from this workshop, this is probably the most important thing, is that the example that you give to your agent beats the principle. So let's take a look. This is a decision I've made to put into agents.md as a principle. So keep controllers thin, and respect separation of concerns. Business logic belongs in the service layer, and services should not be constructed with request specific state. Now, that's all good. Most people reading that would understand, but it's so much better, and this is a really simple example, is to write these out as examples, code blocks. So you could do this for absolutely anything, not just architectural decisions, but an agent looking at an agents.md file with an architectural decision written in code is going to understand this so much better than in written language. So rather than writing this down as a principle, write it down as an example. There's a lot more in here. Yes, it's gonna, there's gonna be a lot more context used up for this, but it's going to be a lot more effective. And in the long run, this is a much better way to do this. So one real snippet of structure you want to reject or enforce does much more than this principle written in a paragraph describing it. The other thing is that negative rules generally work better. So as an example, again, I've made this incredibly vague here, prefer thin controllers. Well, what does that mean? It's a preference. It's not telling our agent not to do anything. And it doesn't really match against anything concretely. But we can say, and there might be multiple of these which are equivalent to the prefer version, don't call DB or model where inside of anywhere in our controllers. This is concrete and it's a very easy thing. It either basically passes or fails. So rules, again, you don't need to write these all up front. The sort of common misconception is I'm starting a project, I need everything defined up front. Well, what you should do is see how your agent works and then correct each time you catch a mistake. That's not just a good idea with architectural stuff, but also just general stuff as well. Now, the issue with any context, but agents.md is stuffing it full of rules. And the more rules you have, the less attention goes on things, or the more stuff you have in there. So the more rules that you have, the harder it is for your agent to see what conflicts with what. So you might have keep controllers thin, you might have don't create unnecessary classes. But then it's like, well, I can't keep controllers thick, or I want to keep controllers thin. I can't add too much controllers, but it's saying not to create classes. What do I do? It's like a conundrum, like the agent does not know what to do. And these come up more than you think, like lots of conflicts, even if they're very, very subtle conflicts. The other issue about a stuffed agents.md file is the whole file loads every single session. And if the rules aren't caught, this is just more cost, both in time and attention. So you want to make sure you prune this your agents.md file every so often. And a rule about one kind of file or structure. So when you look at your architecture top down, a rule somewhere needs to go in that folder. So not just the global file. So this is where you want to put specific agents files inside of nested areas of your application. This is a really good tip. It means that your agent knows what applies to what, rather than having one big root file. This is a really overlooked way to structure agents files. And again, backed up by data, but do not generate your agents.md file from your current application, and don't generate it from a prompt and ask it to fill out a bunch of stuff. That doesn't mean to say don't use your agent to add rules. So I never manually add to my agents file. I always ask my agent to do it. So it will just go ahead and write a single line or a couple of paragraphs, and then I will go in and review it and prune it. These are the things that you do want to be paying a lot of attention to, so it doesn't become an issue in the future. So don't auto-generate it. It feels like you're saving time up front, but in the long run, you're not. So with scoped rules, this is kind of what they look like. Here's one example, but you can imagine them within your own application, the architecture of your own application. You have a Claude.md file within your JavaScript components directory as part of Vue, for example. And this might just be a really simple Claude.md file or a cursor rules file, whatever you are using, agents.md file. And it says components never calculate money, emit events upwards, never mutate parent states. You can just do anything inside of here. And the more of these small adjustment of small rules that you add, it means that every single time your agent goes into this section to change something, it gets a better idea of the structure of your application in the right context, and it's much more likely to do a better job. So this only loads when the agent touches these files, and the rest of the time it doesn't cost anything in terms of context or money. Now, another really important part to take away with, we're going to use this in the next practical. You want to do this in the next practical. How do you test a rule actually works? It's all well and good adding a rule to your agents.md or Claude.md file, but how do you know it actually works? Well, here is what I do every single time. I add the rule. So something goes wrong and I add a rule to agents.md. Then I will go ahead and revert what I did before. So I won't just add the rule and sort of say, well, I assume next time it's going to work. I'll, stash, not necessarily completely stash, but I'll move the work away so I can bring it back later, or I will just completely revert it if it's a fairly small change. Then I will go ahead and I will clear the context. And the reason being is that if you are discussing what's going wrong with your agent, and then you add the rule, and then you ask it to refactor, it already knows what it needs to do. It's not using that rule necessarily to actually recreate the change. So you're then going to run the same task on the rule that you've created after you have cleared the context. So it's like a fresh session and it's like it didn't realize that it did something wrong. It has to read from this fresh rule set, whether that's your root or a nested one. Now, if the rule works and the next time around the agent gets it right, you can carry on. You can't 100% guarantee that it won't do it again, because you never can, but you're pretty sure now that it's not going to again. So you can just continue. But if it doesn't, go back to tweaking the rule, and tweak the rule and then just go through the process again until it gets it right. And again, this process feels incredibly slow, but as you are designing your architecture, as you are thinking about where things should go, where you don't want things to go, this process over and over again and ensuring that this is right means you eventually get to the point where you can ask your agent, please, will you go ahead and build this feature for me? And it pretty much understands exactly where everything needs to go and your preferences. So more time up front, less time in the future. So you're basically investing in your future self. Going a little bit further, we've got a few things here. So ADRs, architecture decision records. I'd not necessarily recommend these for individual developers, but certainly if you work in a team, these can be really helpful. These are basically small decision files. So we'd have a hook inside of agents.md, which would say, well, before changing anything, check the ADRs that we have in our application, which can live anywhere, but we usually put this one like docs ADR. And an ADR looks like this. So it's a sequenced file. So you would have, in this case, we've got 0009. The sort of rough title for it .md, so it's just an MD file. And these will basically have a dated decision. So let's say on this date, we decide that, well, if we send a handful of emails a day, a queue is just too much hassle. We don't want to introduce queues into our application. Email's not a massive part of our application. We handle failures fine. We really don't want queues. So what we do is we add this to this record, so an ADR. And what this is it's a read-only decision. So not physically read-only, because you could technically go in and you could change this, but it's a decision that's made along the way. Now, let's say further down the line, we get to 0021, and we actually change our mind about this. Well, then we create another record in here, and then we have this log of decisions that we've made over time. And this allows our agent to basically work out our thinking behind not only the structure of our applications, but even smaller decisions that we've made. So these could be, as complex as you need, but these can really help as well. And there's lots of frameworks around these, so you can actually generate these using specific frameworks, tools. So, you don't need to manually do these, but worth considering if you were part of a team. Another thing, another really good way to get a feature built or something refactored or fixed in the way that you want it is just point at an existing part of your code. So structure this like app domain billing. If we're adding a new feature, we've already got a structure in place that we want. Why would we try and redescribe it to an agent when we've already got a shining example of how we want this done in our application? So it's real code. We're pointing at real code. It's not a redescription of how we want something built. We might not even need to encode this into agents.md, because if we've got a nice structure to our domain layer and we know what we're doing, then we just point our agent at that point of the application and it can build it in a similar way. Might not be perfect every time, but this works really well because it's actual living code in your code base. It's never out of date because it's current. You're pointing it to the current code base. And agents excel at copying patterns. They're also a lot quicker at copying patterns because they don't need to interpret what you want. They can just copy an existing structure. Another thing I love to do, which feels a little bit like cheating, is just point at someone else's architecture. Remember, we're working with agents that already hit the web. So why would you not say, well, read this blog post and structure the billing module that I want to create in this way? It's a really simple thing to do. Hopefully the website that you are pointing at hasn't blocked agents. Some of them do, in which case you'll just want to go into a reader mode, copy and paste it, or just grab the source code. It really doesn't matter, and paste that into your agent's context and ask it to do this. And again, if the blog post or resource you're pointing at is well written, it will copy it. And we've already spoken about copying our own code. Well, why not go ahead and match a layout of a module, for example, or the entire structure of a entire repo on GitHub. Ask your agent to look at it or pull it down locally first, so you can clone it to your local machine. Of course, your agent can CD around your machine and ask it to do that. So yeah, I'd probably recommend doing that rather than pointing at a public URL, but you get the idea. There's so many shining examples of architecture. Go ahead and point to them. And I actually did this very, very recently with this article just over here. It's a really good article. It's specific to Laravel, but it talks about a monolith, a modularized monolith structure. And I actually structured an application like this very recently. I pointed to this example, this article. It's got plenty of context here. It's got loads of examples. So agents love this because they can see exactly what they need to do. So I absolutely love doing that. It feels a little bit naughty, but it works really well with exceptions. So you don't just want to blindly point it at it. You of course want to be in some sort of plan mode, make sure that it's heading in the right direction. But that's a tip that I would always use. So yeah, a post or a repository that you love is a pattern your agent can easily follow. Okay, we're going to go into the next live now. So we've spoken a lot about how to sort of encode these rules, multiple things that we can do. So you can choose any of these. You don't have to touch your agents.md file if you don't want to. You can use a live sort of URL to structure something, whatever you want to do. But the point is, we want to try and break our rules to then go back and learn how to build them. So if we go back to what we were looking at before, remember, this is the kind of structure that you want to do. So if you are adding a rule, make sure you go ahead and revert any work that failed beforehand. If you have any work, make sure you clear the context out and then go ahead and run the same task and just rinse and repeat. So let's just go through the break your own rules section just to get a little bit more context on what I would love you to do. And then we'll go ahead and do it. So we want to write specific design rules into either your own project or feedback pit if you did pull that down in time. Basically you want to be able to concretely check against these, so it can't be something too vague. Then you're going to switch sides and you're going to write a sneaky task which basically tries to break it. So imagine that you're just being super vague. It's like you don't want it to be obvious. You want to go ahead and run that, and you want to see if the rule held up. So as an example, you might have in your agents.md file, every workflow is an action class in app actions. Controllers only call them. So the sneaky task that you write, bear in mind you're writing rules that your future self could write, or you're writing rules that your teammates might prompt against. So it might seem sort of like pointless. Why are we doing this? Because we already know what we want. Well, other people don't, especially if it's open source. The task might be like, let customers export their data from settings, also add it to the admin panel so admins or support can run it for them. This assumes that we're going to have two pieces of code that do pretty much the same thing in two places. So we're going to basically check, does it follow this first rule up here? Well, it should do, but that's the point. We're checking if it does. Okay, so we're going to have 20 minutes for this. You can go ahead and have a break if you want, or you can think about what we've gone over, and you come back to this and do it later. But I'm going to give you 20 minutes to go and do this. If you've got any questions while you're doing it, please let me know in the chat. I'll be sat here to answer any questions. But I'll see you back in 20 minutes and find out how you got on, and we'll do a little bit of a debrief as well. So I'll see you back in 20 minutes. Okay, we've just got, well, just one over, we've got just over 1 minute remaining. So I'm just going to hop back. Um, I can see that a couple of people have been sharing in the chat what they've been doing, which is great. And of course, if you just took this opportunity for a break, that's absolutely fine as well. But we'll just give it 1 more minute and we'll get started again. Okay, so we're just finishing up. Next of all, we're going to go into a little bit of a debrief just to figure out how we did. But of course, if you've got any questions about the rules that you tried to encode into your application, if something went wrong, if something didn't quite work, or you had a question about a specific thing you're trying to structure, please feel free to ask in the chat and I will answer that at the end of the workshop. Okay, so what got past your rules? These are some of the common problems that we can see happen within rules for our architecture. First of all, the rule could have been too vague to match anything. So this is probably the most common one. The agent hasn't understood it. If you think back to what we were speaking about earlier, and the one thing I said, if you leave the workshop with, this is, probably the best thing you could leave the workshop with, and that is using a specific code example in your rules. So do not structure something like this, or do structure something like this. Giving an ideal snippet of code or an example snippet of code is much better for an agent than writing a vague description of what you want. Next up, if my clicker is working, the rule was one of too many. So you could either have lots of rules in your agents file already and you're adding to them, or just over time you have added too many and they're just diluting all the rest. Similarly, two rules contradicting each other, the agent will pick one. This doesn't just happen within your agent's file, it could happen within your conversation with your agent as you're building something. So you might, for example, have a rule encoded in agents.mg, ask your agent to do something, but actually not want something different, but expect something different to what's already in your rules. The agent will pick usually the latest one, which will be what you've spoken about in your conversation, which is the whole point of this exercise. If you've got something in there, like the example we saw earlier, and you go ahead and ask your agent to put something in one place for one, like a user, and one place in an admin panel, it might duplicate the code, even if you have a rule to stop this. Likewise, the rule might be a preference, not a specific prohibition. And the task can outrank the file. So yeah, the instructions in your prompt can beat the stored rules. Okay, so here's another example of something that could go wrong. In agents.md, you might have money as in integers in pence, never floats, and never divisions on amounts. Now, what you might do is use a prompt similar to this. If someone cancels partway through the month, refund the unused part, their unused money, basically. What might come back is something like this. This is just a made up example, but this could theoretically happen. We get a refund, which is the subscription price multiplied by the amount of days left, however that's calculated, and then divided by 30. So we just roughly do this based on a month, and we use 30 for that figure. Now, the problem with this is this will go ahead and assuming the price is 9.99 with 12 days left, do 9.99 multiplied by 0.4, but that gives us 399.6 pence, and you can't refund 399.6 pence. So does the customer get 399 or 400? So first of all, this isn't specific enough to say, well, actually, this could happen. But it could automatically could also ignore the rule completely. So it's things like this that we need to be really careful with, particularly with things like this, because these are really sneaky and they break things. Okay, so let's go into the next part before we start building up our skill. And this is the two directions agents drift. So there are two ways that agents drift: over engineering and under engineering. Same for developers as well. We both do these things, but agents do it at that 100 times speed. So the signs of over engineering are, for example, an interface with just one implementation. Your agent thinks that a second version or a third version might be coming later down the line, so it interfaces it, and there's really no need. That thing never arrives. It might create a factory for just one thing that, again, it's looking into the future and thinking, well, this would be good as a factory. Something else might come later, when actually that's not going to be the case. It goes ahead and adds changes you didn't ask for. So you ask for a small fix, but you get this trickle down effect of it touching other files and it wanting to go into other files and change something and tweak something else. And you kind of get this snowball effect of it, editing too much. You get a bunch of things you don't want, like handlers, managers, processes for just one job. So one thing split across multiple layers when we really don't need this. And agents like to do this. We also have, which is just as bad, under engineering, which is mostly what we've spoken about here. Lots of business logic in the controller. The same block of code duplicated over and over again. So it will go ahead and just choose to make that simple duplication rather than engineer a solution to stop that. It will pile code on top of old code. So nothing ever really gets tidied up. And we sort of spoke about this earlier with the aversion that agents have for deleting code. And it doesn't consider error handling, and we've seen a lot of that already. And these are just four, but there are lots of ways that things can be under-engineered, again, specific to your language or framework as well. So generally, you'll meet under-engineering most days. Agents will take the simplest way of doing things. Now, that does not mean that this will create a simple application. I want to be super, super clear. That might mean that it takes the simplest path and under-engineers things, but that creates problems down the line later. Over-engineering creates problems down the line later as well, or creates more complexity up front. You need to balance these really, really carefully. Now, one question I always ask myself, I asked myself this 10, 15 years ago: is the complexity justified by the requirement I actually have right now? And or if it's going to be very clear in the near future, and we don't want to really engineer for the things that we might have later, because they usually never arrive. And as developers, we're probably all guilty of this. So this one is really hard because it's judgment. It's not really a rule that you can write down and have an agent follow necessarily. Perhaps some of it you can, but this one you really have to think about. So the way that we do this, and the way that I like to do this, is use a second agent, or the same agent with a different model, or the same agent with the same model but with the context cleared, as a critic. So when I say a second agent, I basically mean an agent that doesn't have any current context about what you are doing or what you are trying to achieve. So there are a few prompts that I use often to make sure my applications are in check. First of all, for changeability, I would say challenge this design for long-term changeability. What change does it make hardest? Now, that last sentence is doing a lot of work, because the first sentence is challenge this design for long-term changeability. Now, that on its own is an incredibly dangerous sentence, because what your agent will do is it will think about scenarios that really, are just out of, they're just never going to happen. What change does it make hardest? That's what you want to know. So you want to know the parts of your application that can be hardest to change if we don't think about long-term changeability now. So that's really, really important to have this entire thing carefully written. The next one is coupling and ownership. So find the coupling and ownership problems in this change. That's a really simple one, but it will allow you to separate out concerns and generally and quickly give you an answer to a better structure, and making things simpler. So I love this one because you can very easily say, and this particularly works well with another agent, basically come in and propose a simpler structure that still meets the requirements. And you might need to restate your requirements or ask it to deep dive on how it currently works. What would we lose? So, what could we take out that would still meet these requirements? And of course, again, you need to be careful here that it doesn't oversimplify and you end up with, say, an action class that's beneficial to your application or some sort of service being removed in favor for dumping everything to a controller. That's technically simpler, but simpler isn't always better. So, you need to use, like I said a moment ago, you need to use your engineering judgment on all of these things. So let's go on and talk about making the critic a habit. So every time you make a change, open a fresh session. So that could be a new agent, it could be your current agent with your context cleared. Ask for problems, not approval. Now, agents or LLMs in generally will always affirm what you want them to affirm. And this is pretty evident if you've used something like ChatGPT. It doesn't so much do this anymore, but there are still hints of this. For example, if you ask it, is a chocolate teapot a good idea? It will generally try and please you and say, yeah, that's a great idea. Like, or is this a good business? Yes, this is a great business. You should do this. It's very encouraging. So asking an agent, is my code good? Or is this solution good? Or, however you want to phrase it, isn't always the best thing. You should probably try to ask for problems instead of approval. And also, really importantly, ask for findings. Tell it not to write the code first, and then afterwards you decide what gets fixed. Now, the reason I like this, and we're going to be doing this a little bit with the skill later, is it allow a list of things that you could potentially change. And of course, it would give you reasons, and you can convert that over into a checklist, a list of things that you can slowly work through. So you don't want to say, please find the problems in this application and go ahead and fix them. You want to ask for problems in a fresh session, and you want to ask it for findings, not for solutions and fixes. And of course, you want to save this process so you don't have to remember all of these prompts and repeat this over and over again. So next time it's just one command. And of course, we're going to be doing that in the next practicals. We're going to be building out a skill. And the critic always finds something. Now, this is also bad. This is good and bad. So you ask an agent to find some problems. It will find problems even if there are none. It will do its best to give you some feedback. It will rarely come back to you and say, no, I can't think of anything that you should change in this application. If you were to ask a coworker, what do you think of the structure of this application as it stands based on our requirements? They'll say, yeah, actually it's okay. I don't think we need to refactor anything just yet. But an agent will not do that. It will try to find something. So for example, if it comes back with something like the discount is worked out in two different places, that's an example we've seen a couple of times through the workshop, then fix that, because that's a real issue. If a discount gets worked out one place or changed in one place, then it's going to break in another place. If, for example, your agent comes back and, this is paraphrased, you could add an interface here for flexibility later on. Probably best to ignore this unless your judgment overrides that and you think it's a good idea. So a really good thing to ask again is, what breaks later if I ignore this? And if you have an answer to that, then go ahead and fix it, even if it's a really simple fix. If you don't have an answer, you can, of course, go ahead and skip it. So we're going to go ahead now and build out a judge, which is in the form of a skill. So let's go and think about what we want to do here. So we've thought about this and figured all this stuff out manually, but we want to write this down now so our agent does it every single time we ask it to do it, and we don't need to remember how to do this stuff. Of course, the benefit of agents is we can have these do things for us. So there are two elements to the judge. The first one is a file, which I've called decisions.md, because I like to use this with other skills as well, but you can just apply this to this one. Alternative names for this, like architecture.md or arc.md, whatever you want to call it. And we're going to, for this, we're going to write down the rules, basically, that we are, deciding on with our architecture, how we want things structured. So this is similar to our agents.md file, but it's sort of not. So the way that this is different is agents.md file. If we think agents.md, if we think about that as directing the agent at the time to write the code we want it to write. Of course, sometimes it's going to miss that or get it wrong. Decisions is going to contain our basic philosophy about how we want this structured, and it's a little bit more in depth. I'll show you an example of this while we're building the skill, because we're going to be doing that together. And we also have the actual skill itself. So this is what we're going to be building now live, and you can either join along or just watch me do it. And I've got the skill ready made for you at the end as well, so you can go ahead and grab that too. So we're going to be using the feedback pit repository, which is part of unlearn.dev. Like I said, we use that for all of the unlearn stuff. And we have a feature flag here called merge duplicate ideas. So what we want to do with the skill, and we'll refer back to this, we want to check the change, the branch, the diff, whatever we want to call it, against every single rule that we've written down in this file. We want to report each violation with the rule it broke and where it lives. Now, when we say where it lives, we want to keep this skill incredibly concise. We don't want it to list all of the files, all of the file line numbers. Skills, when you sort of build them up with agents, will do that by default. So basically, we want to know what area this lives within. And for each one, we want to say what breaks if we ignore it. That's the litmus test for should we focus on this now or not, or should we leave it? If nothing violates the rule, say so and stop. It's allowed to pass. We don't want it, like I just said, to find problems. We don't want our skill to just, try to nitpick problems if there are none. And then for every violation, we want to propose the smallest fix that satisfies the rules so we can fix that. And we want this structured so it's very easy to read, clear, and so we could potentially turn that into a checklist and work on it later on. So the one constraint here is that only the rules live in this file, no other suggestions. So we just want these things in decision.md, and I'll show you an example of this. So let's go ahead and build this. So what I usually do when I start out with a skill, and I'm just going to bring back the list of stuff that we have here so I can refer to this, is I'll go ahead and I've got just Claude open here. I would go ahead and just start by describing very briefly what I want the skill to do. And structurally, I want this to be within some sort of directory. So at the moment, I'm within my sort of overall code directory under skills. And I want this to be symlinked over to Claude so I can run this, test it while I'm building it, but also clear my context or open a new session and do this as well. So let's go and say, build a skill to judge data from, or judge rules from decisions.md and output a list of suggestions. I'm just going to keep it really, really simple for now. Now let's just, while this is running, in fact, let's say symlink, call it judge arch or arc, sorry, and put it in, well, this directory, symlink to Claude. I think it's in, yeah, that will do. Even if you don't symlink, it doesn't really matter. I just generally do this. Okay, let's just hop over to the code here for feedback pit. So let's open this here. And the decisions file that I already created here looks a little bit like this. So these are the rules that I want to set for this application specifically, and these will be built up over time. They're quite simple, but you can go more into depth here. You can add code examples. I haven't here, but I would highly recommend doing that, adding the code snippets here of how you want your architecture to look. So here we've got controllers don't own workflows. A controller translates the request, calls one action, and returns a response. So on and so forth. We've got a bunch of these here. So you'll want to start out with your own, the ones that you want, and you can just add them as you go. Okay, let's go over to here and have a look at this. Okay, yeah, so it's starting to build this out. Okay, so we've got a really basic skill built. Now, if I run judge arch here, or arc, that's going to go ahead and possibly output way too much. I'm going to go ahead and hide myself here as well so you can see better. So this is possibly going to output way too much. Oh, okay. There's no decision log in the repo. Or where am I? Okay. Yeah. So I need to go into. Okay. So we'll use Judge Arc in here and we will build it in here. So this is reading the decision log. And it has 5 rules. Yep. So it's just sort of working its way through them. If you've got any questions as we go, please feel free to put them in the chat as well, so I can answer them as we go. And yeah, so someone's asked, are you creating the skills in code skills in a project independent file to use globally for all projects? Yeah, exactly. And also I can push this up to GitHub as well, which means I can version control it, which is really important. And of course, host it for other people as well. I'll show you the unlearned skills repo a little bit later because that's where this pre-built skill lives, and you'll be able to see the structure of this and how this looks. It's also not necessary to use Fable. No, you can use any agent that supports building skills and pretty much do the same thing here. Okay, so this is taking a little bit of time, but that's sort of to be expected. At least Claude isn't down, or Anthropic isn't down. So what we're going to essentially do here is we're going to keep running this skill as we update it, which is technically going to take the prior context into effect, which is not what we want, but we want to get the structure of this right and what it looks for. So as long as we get the output that we want, then we can eventually, after we've been working on this skill for a while, close out our context or clear out our context, close our agent, and then rerun the skill fresh. That's where you'll notice like the big issues, but it shouldn't take too much longer. Okay, so this should be nearly done. I've got a feeling as well this is going to output so much data. Yeah, I agree as well. Lowering the effort, it's just habit that it's in here. Okay, so yeah, this is structurally pretty difficult to see what's going on, and also we've got a lot of sort of line numbers here and stuff like that. And really the goal here when I'm building something like this is to get the feedback as quickly as possible so I can action it as quickly as possible. At the end of the day, we're human and we want that very clear advice, almost like a colleague is trying to talk to us about the structure of this. So let's go ahead and just start to modify the skill. So we can actually do this directly in here. Okay, so I'm going to go back to the presentation. We want to check the change against every rule in decision.md. We've pretty much done that already. Report each violation with the rule it broke and where it lives. So we have got a line of file of the files involved, but we kind of want this to be a little bit more like this is the area, because remember, architectural decisions are a lot more about sort of the area of your application. So let's just say, since these are architectural, can we avoid using lines, line numbers and files, and talk more about the general area they are? Also, can we structure this so we have a clear title, the rule underneath, or the title as the rule, and then have the, in fact, let's leave it like that. Okay, great. So let's wait for this to go through. If it takes much longer, I will lower the effort. Okay, yeah. So this is much better. So now we've got a sort of clear output of the titles here of each of our rules. But here we've got the rule underneath. So let's Let's use the actual rule as the title. Okay, so let's wait for that to do. Like I said, the reason this is a lot quicker now is because we're not clearing out our context. It has prior knowledge of this, but we're going to clear it out at the end to make sure this is all good. Okay, so this looks good. Now, I don't really want the end bit here. So can we just output the data and not any summaries at the end? So I'll just wait for that to finish because we don't want a sort of commentary at the end of our skill. We want this to be very, very concrete and like, here are the issues. Okay, that's a lot better. So let's head back to here. So for each one, say what breaks if we ignore it. So let's say for each one, can we get rid of finding and can we add the what are we trying to say here? What potentially breaks if this is ignored? Okay, maybe it's just my accent. Okay, so this is a lot better, but I think the actual output of this is a little bit too wordy. Also, we want to know, in fact, I do want to get rid of these as well. But I want to know that I want to know where this exists in my application. So can we bring back files potentially? But I don't want files and line numbers. I want to know the area of the application clearly that I need to head to. Okay, so let's have a look here. Yeah, this is a lot better. We get an overall where. Now, of course, this is bringing out some files, which is fine, but this is a lot better. So I'm just going to double check this because I think it's still. Yeah, okay. So can we get rid of these? And we'll just get rid of them. Okay, so we're still sort of nowhere near done now because I want this to be a little bit better. I'm going to add a little checklist. I'm going to use my checklist skill against this as well to make sure this looks good. So we've got a suggestion here. I just want to make this a little bit more structured. So where, what potentially breaks if this is ignored? We could pop into the actual skill file to change this. Can we make the what potentially breaks if this is ignored a little bit more condensed and clear? Now, noticed also that I've not even looked at the skill file itself. Most of my skills are built this way. We'll take a look at some others as well in a minute. But let's just have a look here. Okay, so this is looking a lot better here. We've got where. So let's just read one of these just to make sure it makes sense. So over in here, we've got one fact, one owner. In fact, do we want these ordered? It might be a good idea to have these ordered so we can reference them easily within here, but let's leave that for now. So the votes and merged votes columns on the ideas table kept in sync by hand in vote controller, mirroring the voters pivot table. What potentially breaks if this is ignored? Stored totals drift from the real count, so rankings and displayed numbers go wrong with no way to tell which figure is correct. Okay, great. So we've got in this branch, we've got some drifting figures that could be different in different places. Yeah, so it says it's already happening. Chained merges, drop the votes, the first idea contributed. Suggestion, derive the merge total. Okay, I want the suggestion to be a little bit more technical. So can you make the suggestion slightly more technical? Okay, so let's just wait for that to finish. Another question, can we run this judge for the whole project? You can, but what I would recommend that you do, in fact, I'll tweak the rule in a second. I'll tweak the skill in a second. Ideally, what you want to do with any skill is make it so you can point it either at a specific section of your application or just the current branch. So I'll show you how to do that in just a second. Okay, now I'm going to leave it at that. just now. I'm going to show you the actual skill over on GitHub in a minute, so you can go ahead and take this. But this is a good start. Bear in mind that each of these are pretty clear to read. We can go through and read them, like we would from a colleague. We have a more technical suggestion now, and you can tweak these. But let's not forget the most important part. Just before I go ahead and add in that flag here, we want to clear out our context before we retest this, because what's happened now is as we're building up this skill, it's taking in all of the context that we're asking, and it's not necessarily writing back. And in fact, I don't actually think this is written back to the skill file at all. Could you write this to the skill file, please? All of this. Okay, and let's just correct that one. And I know this doesn't make sense, but our agent should work out what we're saying. Okay, yeah, so now it's updating the actual skill itself. So that shouldn't take a moment. And then, of course, we're going to clear the context out, or what I prefer to do is just go ahead and exit out of my agent altogether and go ahead and rerun this. So just writing out now. Okay, that's gone ahead and updated that. So we're nearly ready to exit out. Okay, let's go ahead and just quit out of here. We'll go ahead and clear this out, reopen it up, and let's go ahead and run Judge Arch on this, or Arc. And again, this will take a little while, but this should give us a really good idea as to whether everything that we've done, despite the fact we had that context pollution, has actually taken into account. And of course, you can go ahead and modify this based on your own projects, your own structure, whatever you want to do. But the key thing here is that we do have that one source of truth here to everything we want to do. And this could be as many as you want, including, I should have probably included some code snippets in here, but I would definitely recommend doing that. It just means you've got one easy place, also shared with your team, that you can keep all of these decisions in sync as well. So let's just wait for this to go through. Okay, so it's just about nearly done. Now, what I would do, just to answer the question on are we running this or can we run this judge for the whole project? It's not a good idea to do that for your entire project unless it's very, very tiny. So what I would do is I would either do something like this, judge arch, arc, and then give it a section you want to add. Now you can essentially specify loose arguments within skills. So you could say billing area. Now that's enough for your agent to work out where you want to judge the specific area. And essentially what you want to do is judge the architecture only in that area or through a specific user flow, or, even a couple of files you can give it. But what you can do is you can ask your agent to update this and add an argument defaulting to the current diff you have or the branch that you're on in terms of the changes that have been made on that branch. Or you can specify an argument. So I'll do that in just a second. Okay, yeah, you can see here that the output that we get is pretty much exactly what we wanted here. So I'm pretty happy with this. These are the kind of things that can't be built within 20 minutes. You have to build these up over time. Let's just finally add that argument because that's a really good question. Add an argument to the skill to allow a area of our application to be specified. And if this isn't specified, fall back to the current branch's diff against main. Okay, let's just correct that. Again, this might not work perfectly, but you can go in and you can fix that up as well. And I'll just show you what that looks like once this is finished. Again, this first round might take a little while. Of course, we haven't actually looked at the skill file itself, but let's go ahead and have a look at this just now. So you can see it's pretty substantial. Of course, we haven't had to write any of this ourselves, but you can see the structures here, which is exactly what we wanted. So you can go ahead and tweak anything that you want in here. What we'll see though is if we just wait for this to finish, that will start to bring in the arguments for this. There we go. Let's just wait for this to finish here. Perfect. Okay, so this should just be finishing up now. It's added quite a lot more than I asked for, but of course that's just the nature of this. It's fine though. It should be okay. Of course, we can always tweak it. Okay, let's type in Judge Arch now, and here you can see my Claude is giving me this sort of argument here, area of the application, but we don't need to specify this. So you can come in here and change this. I tend to go ahead and square bracket these. It's not actually, it's not pulled it through because it's not pulled through the latest skill file, but you can just basically name that. There are other ways to do this as well, but this should pretty much work for every one. So that's pretty much our skill built. This is how I would start this skill off. But lucky for you, we already have a version of this ready for you to use and change if you want to. So we've already built this, but we have a finished judge here over on the Unlearn repository. I mentioned Unlearn earlier, which is our education platform for developers, but for the AI era and beyond. If we take a look at the skills directory, the repository that we have here, these are all of the skills that we cover either building or using within Unlearn. So you'll learn to build all of these and how they come together and the ideas behind them. There's a ton here across an entire product workflow. And for today's workshop, you have got the Judge Arc skill just here, which you can go ahead and grab. So if you head over to the GitHub repository here, I'm just going to go ahead and pop this in the chat for you. You can go ahead and steal that. Please feel free to fork it, change it to however you want. And it's yours to keep, of course, and do what you want with. Okay, so hopefully that helped. If you've never built a skill before, if you have had trouble with it, of course, I would love to do this for hours, but we don't have time. Just another reminder about the before we go to Q&A about the workshop side door. If you've already signed up, thank you so much. But this is a great opportunity to get this at the absolute best price we're ever going to offer. And you'll obviously get access and earn a certificate, but you'll also get a live onboarding and a Q&A with me as well as this as well. And that's exclusive to this workshop. We really appreciate you turning up. And it closes tonight at midnight. Okay, so we're now going to go over to Q&A. So behind the scenes, we'll have been collecting your questions up. They're going to come up on screen, and I am going to do the best I can to answer them. And we've got about 25 minutes to do this as well. So let's get started. Okay, so we've got here when to define where it's better to rebuild something instead of a big refactor. It really depends. I mean, the thing is, with an agent, of course, this makes it incredibly easy to do either of these. I actually had a situation previously where I had a prototype that I had built. And actually, that prototype that I had built, I had spent a long time building it, over a day. I think it was a weekend, actually. So it was probably multiple days. And I thought to myself, well, yeah, I've created this prototype with AI, which is what agents are really good at doing. But now I want to turn this into a product that works really well. I want the architecture to be good. I want, the security performance issues to be fixed up. What do I do? So that's a really good question. So I would look at the cost to go in and start to either get rid of something and rebuild it or refactor. If, for example, you're refactoring something and it, possibly measure it in human output time, how long would it take you to do it as a developer? Maybe just judge it on that. And then, for your agent, it will be roughly the same, but of course, an order of magnitude like quicker to do it. So yeah, I would really, really good question. I've not thought about it before, but I would judge it on human, how long it would take you or the amount of effort it would take you. And then I would use that to decide whether to hand that over to an agent or not. Okay, how can we make sure that our rules are being respected? I have a review rules file that has a specific review skill use. I also have some rules in docs. Yeah, again, good question. I mean, a lot of what we've covered in the workshop is how I would do it, and I've had a lot of success with doing this. For context, my goal with AI, with building with agents, I was very skeptical, but my goal now is to be able to hand over a spec to an agent, have it build it exactly how I want it built correctly almost the first time. So I would use all of the stuff that I've taught you in the workshop is like everything that I would do day to day. It's not advanced, it's not complex, it doesn't need to be. But all of the quality of your rules files is the most important thing. So I would take that knowledge. I would try to get really good at writing really good rule files, stuff in your agents.md file, and I would focus on that and test it over and over again. Rewrite the rules, see how well your agent does. It's a real slog. It's a long process. But the great thing about this is that most people use the same framework over and over again, or the same language over and over again, or they use Laravel and Vue, or they use Rails and Vue with inertia, perhaps, whatever. So you can actually transfer the rules that you've spent hours and hours building up to another project. So don't feel like it's, wasted time just for one project. You can transfer an agents.md file, which is what I do for pretty much every project I build. Can we get the skills repo URL? Yeah, I'll just paste it in the chat one more time. Okay, I've just pasted it in the chat, so that should come through. Does it make sense to write any specific error it makes inside the MD? Won't this lead to overloaded rule set, which causes the agent to get confused? Yeah, I would. I'm guessing what you're asking is if there's some sort of error or issue, would you then put that inside of agents.md? I would avoid that. I would more focus on the structure of your application, and like I said, the actual solidified code examples is probably the best thing to do. So, yeah, I would keep your prune and look after your agents.md file as much as you possibly can. Does agents MD work better than rules directly in the system prompt? Yeah, that's a really good point. Yeah, so this isn't an alternative to the prompt. Now, I'm a massive fan of not just upfront planning, but specifically spec-driven development. Now, the thing with spec-driven development or using plan mode, plan mode is great as well. I'm an advocate for any kind of plan mode within an agent. I would. I'm still getting the link not coming through in the chat. Let me just pass it over so that can go up on the screen. Let me go back to the question. Yeah, so I'm a massive fan of planning up front, whatever we do. So I won't prompt my way to a feature. I won't prompt my way to a bug fix or a refactor. I will use either plan mode or I will use spec-driven development. So what will happen is when you get into the habit of planning up front, which is a whole other thing, we've had a workshop on this before as well, you can review what your agent is about to do before it does it. So the benefit that you get there is you've got an agent's MD file helping you, structure that plan essentially. Like that plan will be a detailed plan of what's going to happen. So that's your first line of defense. But then you spend time planning something rather than prompting your way to it, which allows you to review whether your agent has actually listened to your agent's .md file in the first place. And then, of course, you can use prompts to tweak your spec or tweak your plan, whatever you need to do. And then you should be at that point where you spend, the majority of your time upfront planning, but then you can just let your agent build and hopefully walk away from your machine and just let something get built. That's the sort of goal for me. And that's the stage I'm at the moment with everything that I've discussed today. So yeah, it doesn't work better, but I think it works really well in conjunction. How long does it take to become comfortable with this process of getting AI to reason critically about code? Um, Really good question. It takes a little while. I would say I don't blindly trust an agent to judge code. You have to have knowledge about what you are doing beforehand. Even if you don't have a huge background in software engineering, you still have to understand what the agent is doing and the things it's most likely to do, and also the things it's most likely to say as well. So I would, because we're getting a huge amount of developers that are coming in who don't have that traditional background of writing code by hand, which is fine. Like everyone should be able to use AI to build what they want, but you need to understand what you are doing or what the code is doing before you trust AI to do it. So it's a great question, but it depends on how good you are at uh, at this stuff. Basically, you ask an agent to judge a piece of code, if it's more or less right or more or less wrong. So yeah, it of course depends, but hopefully that answers your question. If I'm not an expert on a topic, how can I know whether the solution proposed by the AI is the most stable one and whether it follows programming guidelines and standards? Again, good question. And I'm sort of going to give the same answer as the last question. The answer is you don't really know. But what you can do is you can figure out as much as you do know and make sure things are consistent. Now, I'll give you an example of, let's say you build out an application and you're not really quite sure that a particular structure or a particular pattern is right, but you use it anyway. So validate in a certain way, or you use action, perhaps you use action classes, or perhaps you use the repository pattern. Now, the repository pattern isn't as popular as it once was, but let's say that you think it is, and you go ahead and you implement an application. As long as you're consistent with what you do, even if it's not quite right for your project, as long as you're consistent as you go and you've got them rules encoded, it's going to be much easier to refactor the structure, architecture of your application later on. So the solution proposed by the AI might be, in terms of architecture, might be really bad. But again, it's not, as long as it doesn't affect the performance or security of your applications, which is not what we're talking about today. We're talking about predictability and how predictable your application is for an agent to dive in and work on your application. So it might not be the best structure. You might not know everything about it, but that's fine. What you want to do is be as consistent as possible, so it's easy for your agent to refactor later. If you don't, and if you ignore that, you're going to end up with an application that is just filled with so many different patterns. It's going to be a huge mess, and you're basically going to have to scrap it and start again. So yeah, really good question. But just do your best and keep as consistent as you possibly can using what we've spoken about in the workshop, and you should be good. What defines ridiculous amount of MD files, especially in a team? Um, There's not really a definition. I mean, there are huge MD files. I think the most important thing with any kind of any markdown files, not just agents.md, ADRs, whatever you have in your application, spec files, if you're using spectrum development, it's not really about how much there is, because context windows are ridiculously large and they're only going to get bigger. It's more about if they contradict each other, and it's more about how well they're managed. So as we spoke about in the workshop, if you have an agents.md file with an auto-generated list using AI of stuff, it's, that's all worse technically if it's shorter than having a huge list of well-defined concrete rules with lots of code examples. If you think about it, it's like it's a balancing act. You could have, let's just give a random number, a 10,000 line agents.md file with tons of code examples in for exactly how you expect your application to be structured. And I'm talking almost like you're writing a book about how your application should be written. Compare that to a shorter but more vague and more repetitive agents.md potentially generated with the agent itself. Which one is going to do better? And also, which one is going to have the best end result? Well, the first one will probably be quicker and it will probably cost less. It won't fill up your context window as much. However, the latter will do it it's more likely to do it right the first time. So it's really about upfront thinking. And it's the same argument as using cheaper models. Lots of people try to use cheaper models to save money and obviously their usage depending on the setup. Well, that's great. But if you're using a cheaper model and it's taking you 3 times as much back and forth to get something working, then that's worse, both for your time, productivity, cost. It's like buying cheaper things isn't always better. It's better to invest up front so things last. And you can very easily do that with a markdown file or a bunch of markdown files. So to answer your question, I don't know what defines ridiculous, probably, millions of lines, but definitely the most important thing is keeping everything in sync with the team. That is difficult, and I don't have an answer for that, but yeah, definitely make sure everyone's on the same page and make sure that's documented really clearly for everyone's agents. Okay. How important is today to know a framework like Angular or React inside out when using agents to help you build? What has more impact? Knowledge of how to build or what to build? Okay, really, really good question. So sort of touched on this. Like, it's really important to understand the fundamentals, I think. But yeah, it's also it's a difficult one. It's important to know the fundamentals, not necessarily the syntax. I would say syntax is like, probably something that most people don't learn now and probably shouldn't learn. I'll be totally honest with you. I'm a Laravel developer, but I haven't opened up the Laravel docs in over a year. I haven't looked into the Laravel source code for over a year. I used to go in to find out how things worked. I haven't really opened my editor for about a year. I would say I'd probably open it about 5% of the time just to check things and get these rules encoded based on what it's outputting. But you can judge that from the CLI as well. So to answer your question, I think it's important to understand how a framework works, especially if you're new, how general software engineering concepts work, understanding what a database is, what a cache is for, what validation is and how important it is, and performance and, all of the abstract stuff. But I don't think syntax or diving specifically into things is that important anymore, as long as you have a good general knowledge of something. So like for Laravel, for example, I don't need to keep up to date with it. I can do that, once every 6 months. I can just dive in and see what's totally new. So yeah, I would say not super important. It's not that important. It's more important. The most important thing is how to guide your agent to build things that are fast, secure, easy to maintain. When building the agents, having the same approach as a generic description. Sorry, let me read this again. When building the agents, having the same approach as a generic description plus code examples will assist in getting better results. Yeah, so I assume you mean giving code examples when you are building with an agent will get you better results over a generic description. And yeah, that's true. So definitely, if you, like I mentioned in the workshop, if you point to a specific part of your own application and say, build it like that, or use that as inspiration, you give an existing repository or an article, whatever, to sort of give code examples, yes, it's likely to do a better job. Not always, but I would recommend doing this within plan mode, so you can actually see how it is, how it's taking that data. So just to sort of go back to this, I use this to convert basically a prototype, a mess of an application, over to a better structure. And I would say it took 3 or 4 goes of of sort of refactoring to get this right. And every single time I learned what didn't work, and I changed the way I was describing how I wanted this to work, and giving sort of like not this entire article, but I was pulling out parts of the article. So you just have to be really careful about what you do give in, but it's definitely not foolproof. But yeah, much usually will get better results. Okay, so next question. To help having better and more specific context, can we create MD files in feature folders instead of root, specifically as the code grows a lot? Yeah, absolutely. So you can use this is documented, for example, over on Claude. I pretty much exclusively use Claude Code, but this is the same for other agents as well. You can um, you can plant specific context where you need it, which we did cover. So you would basically create an agents.md or a claude.md file, or whatever agent you're using, in a specific location in your application to give better context at that point. So yeah, definitely, as you get to larger applications, helps with applications broken up into modules as well. So yeah, definitely. I'm wondering what these architectural rules are based on. What I'm thinking about is the good old software engineering principles and philosophies. Yeah, I did see this question earlier. Yeah, so personally, like the examples that I gave in the workshop were just personal things that I would do in a very basic application. I couldn't add more advanced, principles in here, because it would just, first of all, confuse between different frameworks and between different languages. I had to give very specific, simple examples. But the rules can be based on anything, as we sort of discovered later on into the workshop. It doesn't really matter what your rules are. The point is, you need to know what to spot. There's a general area of bad things that you should probably not be doing. I'm looking at this as through the lens of someone who has never really thought about architecture, but they're using agents daily. So spotting those patterns, and there are lots of other patterns that you can look for. The point is understanding them patterns, first of all, then going ahead and encoding them rules into your application, testing them, making sure that they don't come up over and over again. So the rules that I use are just based on like the very basic principles that I would advocate in applications, and they're very simple to define, and they're very simple to enforce. But you can, of course, once you've got the basics down, start to expand on this, add more and more complexity to your rules and your architecture, giving code examples and everything that we've already covered. And you'll end up with a very, very good documentation of how things should be built. And your agent will, 99% of the time, if you've taken care to do this, follow these through. Same prompt with 2 different models will always result in a different solution. How to choose which is better? Oh, good question. So again, this is quite subjective, because the better solution really depends on what you are aiming for, and this is the kind of judgment that you can't give up to AI. You still need to work out whether something is works or not. But a technique that I use sometimes is I will build something in one agent. So let's just use Claude and Codex as an example, because I use Codex maybe 20% of the time as my sort of review buddy. that sits on the side, both for code review and architecture stuff. So I would probably say, well, ask Claude to build the feature, and then I would ask Codex to review it. But I would then do it vice versa. And then you would, if you're still sort of learning these basics, you would then probably get a better idea of which one is better based on the output. Now that's not a rule, and these things can go really wrong because, like we've seen, agents can agree with you. They can also, of course, hallucinate. So this is not a foolproof solution. So really, the fundamental part of choosing which is better is about choosing or about knowing which is actually better for your use case. There's no good architectural solutions for everyone. But there are some common basic things that everyone should be doing. So yeah, you can compare them to best practices if we're still using that word, but you can also ask two agents to effectively fight over which solution is best. So there are lots of different ways to do this. Is the cross check with different AI a good strategy? Yeah, so kind of like the same question that we've just asked. Now, it has its place. It almost feels like I've seen a lot of people do this. It almost feels like you are verifying that something is correct, but we know that's not always the case. So we have like a code review skill over on Codex, for example, that code reviews a piece of your code. The point of using a cross check is choosing a model that is better at, for example, code review than the current model you're using is. You might have a really good model that it sounds sort of counterintuitive, but you might have a really good model that writes code and can engineer a solution. Then you might have a really good model that's good at code reviewing. This is generally what I do. I tend to use Codex as this sort of review buddy. Again, I take all of the advice with a pinch of salt. I don't ask it to change anything, so I don't ask Codex to then go in and change stuff. And to be honest, sometimes, and this sounds really strange, I will use a more traditional sort of chat-based LLM like ChatGPT just within the UI on my Mac to talk about how an application should be structured or the decisions it should be made. And then I'll ask ChatGPT to then create a prompt that I can then feed into Claude. Now, I know that sounds mad, but actually, a lot of the time, having another agent to sort of talk to as an engineer rather than write code for you works really, really well. And you could use another agent on the command line to do that. It would be the same thing. But I find that really helps. And it's a technique that I've used in some incredibly complex problems. The benefit that you get as well is that you can make decisions based on lots of other software that's already been built, and it's really clear to see as well. It feels like you're chatting to someone, which is always good. Okay, how helpful is it to assign an agent an identity or persona? You are an experienced, knowledgeable system architect with a deep, broad understanding and appreciation of best practices. Yeah, I mean, essentially what you're doing when you do this, this is a cool technique to use, and I've seen a lot of people use it. What you are essentially doing here is it's a prompt. Like you're not actually changing its training data. You're training the way it responds and the things it focuses on. So rather than doing that, for sub agents, it's fine. So you might have a sub agent that's a documentation writer. So when you write something and you just about to sort of push some code, or when Claude makes a change, you might have a hook with a sub agent which writes out your documentation. In which case, yeah, you would write, you're a documentation writer. But I think for critical things, it's much more important to define out things like we've done today in a skill. So nowhere in that skill I would write, you are experienced in architectural design and all that kind of stuff. It does help because it narrows the focus of the output, but it of course doesn't change the overall characteristics of a model when you do that. So I would say yes, it is helpful, but just remember it's still a prompt. It controls the output. It doesn't change the the full characteristics of a model. Okay, so how do I fix the issue? Rule was one of too many. I'm not sure what that refers to, but feel free to add in the chat, and we can pick up on that as well. Does an MCP server like Laravel Boost impose a repeated load on an LLM? Yeah, I was actually thinking about this earlier because when you install Laravel Boost, for those of you that don't know, Laravel Boost is an MCP server that gives you access to things like documentation, access to log files via its MCP server. So it's very, very good at understanding your application. It understands the roots in your application. Very, very easy. So it's better specifically for Laravel to build with this. And other frameworks have similar things. But the one thing it does do is it fills your agents file with a lot of stuff. Now, a lot of this stuff is like hooks and triggers and very specific things. And actually, there are a lot of code examples in here. So I do tend to leave that. But what I do is I break my agents file up and I have my like own specific rules and then the Laravel Boost stuff. In terms of imposing a repeated load, I don't think so. It gives some really helpful context, and there's a lot of data to back up that using Laravel Boost does have a really good impact on applications when you build things, both in like the time and the accuracy of building things. So even if it does impose a little bit more context, of course, it's going to fill up context more. I think it's definitely worth it. Okay, I think we've got time for maybe one more question. So the Laravel ecosystem has come up, another Laravel question. A Laravel ecosystem has come up with numerous packages for building RAG and AI agents. Would you be considering reviewing those and coming up with a lecture on this? Please do so, Alex. I can't promise anything, but possibly, yeah. There are lots of great packages around all frameworks, to be honest, of course. Like the great thing about a framework that I love is that a framework imposes a very strict structure. So when we are actually talking today about architectural decisions, a lot of them architectural decisions have already been made for you within a framework. So if you do have something like an MCP server for a particular framework, make use of it because it will understand the framework a lot better and it will give you this better builds essentially. The thing I specifically love about Laravel is, and I believe Rails is the same, is there are very strict conventions on what you should do and what you shouldn't do. I say that lightly because, of course, everyone's different. But if you have that strict structure, then yeah, it works really well. So yeah, I'll definitely consider reviewing some of them. But yeah, I can't promise anything. But stay tuned. Okay, thank you so much. Once again, if you did want access to the side door for the AI certificate, there's a QR code on the screen. Please go ahead and scan that. There's a bunch of information on there before you decide, but I would love to see you inside. And just remember that gives you the lowest price and access also to a live workshop and Q&A session with me as well. Okay, so I'm going to say thank you so much for joining. I'm actually going to be hanging around in the chat for about sort of 10-15 minutes afterwards. If you have any burning questions that you couldn't get through, if you have any feedback, if you just want to talk about anything, I will be in the chat. I won't be on screen, but I'll be there to talk. So once again, thank you for joining, and I will see you next time.